Okay, let's look at this technique of finding square roots of complex numbers. So let's, for example, take an exact number 3 plus 4i, and we want to find the square root of that complex number. Now what we've got to do is a little technique here, and it goes through here. So take a note of what we're doing. Now, basically we're solving this situation. X plus iy is some complex number which is the square root of 3 minus 4i. So X and Y, keep in mind that they are real numbers. Okay, it's a complex number and you've got the I there, so Y can't be an imaginary number, because an imaginary number times an imaginary number would give us a real number. So that's the first thing to note. X and Y have got to be real numbers. So when we look at that, to simplify, what we're going to do is square both sides. So X plus iy all squared would equal 3 minus 4i. The square root's gone. So that's our first step. We're going to expand this out. So x plus iy all squared, and expand the two brackets. So x times x gives us x squared. Iy times iy gives us minus y squared. And then we get 2xy times I. Now I've split it up like that because, again, I've got my real parts here, and there's the imaginary part of that complex number. So that's going to correspond. Remember what we said before is that if two complex numbers are equal, the real parts are equal, so x squared plus minus y squared is equal to 3, and the imaginary parts are equal, so 2xy would equal minus 4. So we can come up with those two situations, because what we're going to do is find the values of x and y, but we've got two equations that are in x and y. We need to do some simultaneous equations here. So 2xy is equal to minus 4, so divide by 2x gives us a minus 2x on y, minus 2 on x. So what we're going to do is do a substitution. Put that into this equation here. So x squared minus 2 on x all squared is equal to 3. Multiplying that one gives us a 4 on x squared. And we don't really like the x squared on the bottom, so we'll multiply all the way through by x squared. So we're just solving a quadratic as such, because even though it's a quartic, we're going to reduce it to a quadratic as such, because we can treat it and factorize it down here. A lot of times these ones will factorize nicely. Again, if not, use the quadratic formula, treat it as a quadratic and solve the quadratic formula. So we get x squared plus 1 times x squared minus 4 is equal to 0, which means, remember, x and y were real numbers. So if we're looking at x squared plus 1, that can't be solved with a real number. That's going to give us an imaginary number, because if x squared plus 1 was equal to 0, x squared would have to be equal to minus 1, which means x would be equal to the square root of minus 1, so x would equal plus or minus I. Okay? X can't be equal to y because x was a real number there. So x, we only take the real solutions of this quadratic equation, which means that x can be plus or minus 2. So when x is equal to 2, y would be equal to minus 1. When x is equal to minus 2, y would be equal to positive 1. So there's our value. So we get 2 minus I, because the y was minus 1, so 2 minus I, or minus 2 plus I. There's our two square roots of our complex number 3 minus 4i. So that's the way we're going to do that. We set it up so we've got we square both sides. We expand and equate the real parts and the imaginary parts. So we basically are working with just the x and y's. And then we only want one variable, so we will do a substitution and then solve for one of the variables. You could have solved for y and solved the equation in y there. That wouldn't have been a problem as well. Do a substitution for x, same thing. You'll end up with the solutions there. Okay, so that's our technique. Let's have a look again. Let's find the square roots of 8 plus 6i. So again, if we let this situation occur, x plus iy all squared is equal to 8 plus 6. So we squared both sides, expanded our left hand side, and equated the imaginary parts. 2xy is equal to 6, or xy is equal to 3 on x. Equated our real parts, and got x squared minus y squared is equal to 8. Do the substitution. So we substitute in there. So x squared minus the 9 on x squared is equal to 8. Multiply through by the x squared and get our quadratic equation, where we can get down to a nice factorization. So we get x squared minus 9, x squared plus 1. So again, notice that we're not going to take the x squared plus 1 because that will give us imaginary solutions. We're just going to take it so we can get real solutions for x. Because when we get x is equal to 3, as we can see, we get y is equal to 1. And when x is equal to minus 3, we're going to get y is equal to minus 1. So doing the substitution there, that's the easiest substitution. You can do it that way, but that's the easiest substitution there. So we get 3 plus I, it's minus 3 minus I, which can be written this way. 3 plus I with the positive out the front. If we put the negative out the front, it would be minus 3 minus I. So that's how we find the square roots of complex numbers. Have a look at that process. Know it well. These ones will come up by themselves, or you can get them as part of solutions to other problems, as we'll see in the next video.